from the liquid to gas. Now, we are told that put 10 centimeter cubic of concentrated copper to sulfate. So copper to sulfate, it is a mixture now. It is a chemical, but it is a mixture of copper and the sulfur. Some aspect of sulfur into an evaporating basin. Arrange the apparatus as shown. It has been arranged for us. And then they are saying, using a water bag. Do you know the water bag? Do you know the water bag?
Yes.
Do we know the water bag? Okay. Heat the solution to evaporate excess water. As heating continues, dip a glass rod into the solution regularly and allow it to cool in the air. When crystals start forming on the glass rod, remove the evaporating basin from the water bath and allow it to cool. So after heating, after some time, for sometimes, then you allow it to do what? Cool. Then record the observations there. Now, what are some of the discussions? After this experiment is done, what are you able to see? One, the glass rod is dipped into the solution to find out whether the solution can form crystals on cooling. So don't worry about this because we conduct a practical on this before the week ends, okay?
Yes.
Then, to find out whether the solutions can form crystals on cooling. Number two, we are seeing when crystals form on the glass rod. When a crystal forms on the glass rod, this is an indication that the solution is ready to form crystals. It is an indication that the solution is ready to form crystals. We're also seeing that at this point, the solution is to be saturated. Saturated simply means the term saturation. Saturation. Now, who can try? What is saturation? Saturation means, you see, whenever you are adding sugar into a tea, are we together? So you will add the first spoon, then you try to stir, it will solve completely, right? You add another spoon, as you stir, you realize some sticks to get at the bottom or settle at the bottom of the glass. It does not really dissolve anymore. So whenever as you add more sugar, you realize that it will not dissolve. Are we together? That sugar will not dissolve in that tea because it has reached its saturation point. Meaning even if you add more and more sugar, it won't dissolve. So what I'm trying to say is that whenever you're adding sugar into tea, as you add more sugar, you realize that it won't dissolve at some point. Meaning that tea there has reached its saturation point. That is what is meant by saturation. So it will no longer absorb more sugar. You just add that this sugar you are adding will settle at the bottom at the bottom of the glass or whatever the container you're using to take your tea. So we are defining a saturated solution as one with no more solute can dissolve at a given temperature. So we cannot, even if you add more and more sugar, you realize that it won't dissolve. Are we together? You add the first one, second one, the third one, you just realize that if you start, you see several or some amounts, good amounts of sugar settling at the bottom of that glass. So that is a saturated solution. Same time to let's try salt. You are adding, maybe even today you can just take salt and then water. Add that salt to the water, first spoon and then stir. See what will happen. Add another one. Try to add more. As you add more, it won't dissolve anymore in that solution or that solid. So it means that it has reached its saturation point. Now, the process of obtaining crystals from a saturated solution is known as crystallization. So we are saying that crystallization is the process of obtaining crystals from a saturated solution. Then this method can be used to separate most soluble substances from the solution. So suppose you mix sugar and water. Are we together? So you mix salt and water. But you wanted now to separate. Remember, our discussion of today is that we are talking about evaporation. We want to see how can you get the sugar back Are we together? So the process is called evaporation. You are trying to heat so that at this point we realize that glass rod is being dipped inside to testify whether the crystals are formed yet. Now as you heat more, there is one which is going to evaporate, leaving what? Leaving, so the water in this case is going to evaporate, leaving the crystals to be formed that is being tested using the glass rod. Now we are saying that this method can be used to separate most of the soluble substances from their solution. Now, applications. Where do we apply evaporations? Applications of evaporations. Where do we apply evaporations? Applications of evaporation. Where do you apply evaporation? Number one, extraction of salt from salty water. Whenever you are extracting salt from salty water, do you know some of the examples of the salty lakes or water we know around? Do you know them? That is it in history or social studies? Some of these lakes, which are salty, do you know them? Like Lake Magadi. So we realize that in that lake, water which is inside that lake is salty. But through the process of evaporation, you are able to extract the salt from those lakes. Are we together? So that is one of the applications of evaporation. Number two, okay, we are talking of the examples of lakes at Lake Magadi and Gomeri in Malindi. Then number two, we can as well say that evaporation can be used in the extraction of sugar from sugar cane, from the sugar and sugar cane. Like, do you know how Skariguru is being made? Do you know how Skariguru is being made? Who has seen? So, this is how it is being made. You see, whenever they bring in the sugar cane, okay? Whenever they bring in the sugar cane, there is a machine whereby they pass the sugar cane through. So as it crushes the sugar cane, so the water from the sugar cane is being collected. This water is sugary. Are we together? After being collected in a kind of frame, then there is a big tank, kind of circle shape, which is being heated. So they will transfer whatever has been gotten from the sugar cane, this water here into that tank. So as they heat it more and more, the water that is there will escape or will evaporate. How will it evaporate? Through the smoke as we will be seeing, okay? So as it evaporates into the air through heating, then at the end of the day, you will realize that what we will be left with is the sugar, which is now the Skariguru that we always eat. So that is one of the examples of how to apply evaporation. Evaporation simply means you add a mixture of salt and water, or you add a mixture of sugar and water, but you want to get the sugar back. Are we together? How do you do it? You put the solution containing water, the mixture itself, on the evaporating what? Dish. Then heat it through the setup that we just see. As you heat it, you realize the water will escape. As water escapes, the crystals of the sugar will be left on that evaporating what? So that is an application of evaporation. Number two, extraction of medical substances from plants. So how do we extract the medical substances from plants? This is done through evaporation. This is done through the evaporation. Now, if you go back to this exercise that you asked, there are some of the questions I asked there. So you can try them at your internet. There are questions which are asked like, why is the glass rod dipped into the solution while heating? So what we'll do, I don't know if there's going to be a free lesson today. Yeah, so at this free lesson, there's no life skills. Who teaches you? But does she come? No. So I think we use that time to do an experiment of this, okay? So that we are not left behind. Remember, our interest is to finish the syllabus. That is by, I want us to stop tomorrow, then we start focusing on the revision for the end term exam. That is just around the corner. So, copy the notes. Are we together? From under evaporation. Where did we stop last time? It was? Where did we stop last time? So, you will continue up to application. Are we together?
Yes.
Up to this one. Is everyone able to see? So you write the application. So that is where you stop. So from there, I think you stop there, that is from today, and then you start to do the revision. the exam that is about to come. You can just measure